Hi all, welcome to CPP Flex YouTube channel. In today's video, we will discuss about standard numeric limits. STD numeric limit has been around for a long time. It was introduced in the very first standardized C++ and it is improved over newer standards of C++. Let's see what's there in STD numeric limits. The limits module of the standard library makes available upper and lower limits for various types. Limits available for all the fundamental data types, so you can directly use it in your program. STD numeric limit is a class template that gives information about the properties of arithmetic types. For example, in order to display maximum value you can store in a variable of type double, you could write like this. You can use STD numeric limits double of max. Here you can replace the float by any other fundamental data type. Also you can replace max with min to obtain the minimum value that can be stored. But the meaning of minimum is different for integers and floating point type. For an integer type, min result in the true minimum, which will be a negative number for a signed integer type. For a floating point type, min returns the minimum positive value that can be stored. It is not the most negative value. In order to get the most negative value, it provides another member called lower. So, what the use of STD numeric limits? It's a portable way to get type limits. Instead of hard-coded in max, double max, we can directly use it in our program. It handles all the arithmetic type, including user-defined specialization. It is useful in numerical algorithms, error checking, and generic programming. These are the important members of STD numeric limits. For integral types, min returns the smallest representable value. It's similar to the hard-coded in min. Max returns the largest representable value. Digits return the number of non-signed bits, means the total number of bits excluding the signed bit. Is signed. It returns true if that type is signed, otherwise false. For floating point types, min returns the smallest positive normalized value. Max return the largest finite value. Here comes the lowest, which will return the lowest value, means the most negative value. So for an integer type, we can display the minimum and maximum value using min and max. Here in floating point numbers, we have to use the lowest and max in order to display the most negative and the most positive value. Epsilon returns the difference between 1.0 and next representable value. Infinity returns the representation of positive infinity. Quite NaN. It's simply the quite NaN value, not a number, means without throwing any exceptions. Denom min returns the smallest positive subnormal number. Let's go through the example. I will run the first part of this example. See, it will display the minimum and maximum values for this particular data type. For short, it is from this range to this range. Shortest of 2 bytes here. So it will be 2 raised to 16 divided by 2. For int, it is 4 bytes. So 2 raised to 32 divided by 2 will be this number. For unsigned int, there are no negative numbers. So it will be this range from 0 to double the value of this. For floating point numbers, the range is like this. Here for integers, it is displayed using min and max. Here for floating point numbers, min will display the lowest positive value. Max will display the largest positive value. Here, lowest will display the most negative number for the float range. Let's go through the second part of this program. So first it will check it is signed for int. Yes, int is a signed data type, so it will display true only. For unsigned int, is signed will display false. Next, it is displayed the digits for an integer type. Integer is of 32 bits. The first bit represent the signed bit, so digits represent 31, excluding the signed bit. For unsigned integer, it is 32. For float, we are printing the epsilon using that member epsilon, and also we are displaying the infinity using the member infinity. So here I have covered all the important members of standard numeric limits. Yeah, that's all for this video. Thank you. Bye.